All right, this is a pretty brief, straightforward lesson where we're going to look at how to calculate molecular mass. So, the molecular mass is basically the mass of a molecule. Now, we know from our previous learning that the mass of a atom primarily comes from the number of protons and number of neutrons in the nucleus because they are significantly bigger than the electron. And they both have a mass of 1 atomic mass units, or AMU. So if we go and we look on our periodic table, and I'm going to apologize, mine's sideways. I don't know how to fix it right now, so we're just going to deal with it. But you're going to want to look at your periodic table, one that says Alchem periodic table of elements. And if we zoom in and we look at the top, if we look at the top where this key is found, we're going to see that there is a number right here on our periodic table where it says atomic or molar mass. Now, don't worry about molar mass, grams per mole for now. We're going to learn what that means a little bit later. But what this number means is that one atom of hydrogen has a mass of 1.01 AMU, or atomic mass units. And you're probably wondering, well, like, how do you have a 0.01 of a proton or 0.01 of a neutron? And you have either have learned or will be learning soon that this is a weighted average of the isotopes of hydrogen. So we'll talk more about how this 1.01 atomic mass units number came from in a different lesson. But for now, what's important is this is the atomic mass that we will use for hydrogen. Okay, so all of the elements on this periodic table have an atomic mass in the top right corner in their box on the periodic table. Okay. So if we go back to our little note, and you're going to want to copy this down as we go through this, we're just going to quickly go through how to determine the mass of a molecule and do an example. So molecular mass, basically, I already told you, is the mass of one molecule. And we measure it in AMU, so our atomic mass units. And that atomic mass units has the symbol of essentially a fancy cursive U. Now, this should be pretty straightforward, but basically we calculate our molecular mass by adding up the atomic masses of all the atoms in a molecule. And that should make sense to us because we know our atoms have a mass and we know our atoms bond together to form a molecule. And so if we wanted to know the mass of the molecule, we just add up the masses of all the atoms that make up that molecule. So if you don't have this copied, just hit pause, get it copied. All right, so we're going to do an example where we are going to calculate the molecular mass of water. Super easy. So calculating the molecular mass of water, what we have to do is go to our periodic table and get the atomic mass of hydrogen and the atomic mass of oxygen. So I'm just going to write down my givens. Atomic mass of hydrogen equals, and atomic mass of oxygen equals. And I'm going to go to my periodic table and I'm going to look. And right here for my hydrogen, we've already checked this out, but we know is 1.01. So I'm going to write this down here, 1.01 with my units, U. Then I'm going to go find oxygen, and I know oxygen's way over here. Again, I'm sorry, this is upside down or sideways, but here is the atomic mass for oxygen, 16.00. So I'm going to write that down here, 16.00 U. All right. So because we're going to do this in proper format, I'm going to write out what I'm looking for. I'm going to write molecular mass of H2O equals. Now, it is going to be, so it's the sum of all the atoms in the molecule. Because our water has 2 hydrogens, we have to multiply the molecular mass of water times 2. So it ends up being 2 times 1.01 U plus 1 oxygen atom. So 16.00 U. There's only 1 oxygen, so we do not have to multiply that by anything. Because we're doing this in we're communicating in proper scientific formats, you're going to notice that I have included my units for all of my measurements or all my numbers that I have. Okay, so that's proper communication. So this ends up being, I'm going to write out all the steps, 2.2 atomic mass units plus 16 atomic mass units equals 18.02 atomic mass units. Now, this is pretty straightforward math. You do not have to show me all of the steps, but you should always be showing me this step and your final number. Okay, the rest your calculator can do for you. And again, we're going to communicate this properly for scientific format. So we're going to write a therefore statement. Therefore, the molecular mass of water is 18.02. Now you can write the unit here or you can write it out in words. Okay, so calculating molecular mass, very easy, very straightforward. I want you to, make sure you have this copied. Hit pause, get a copy down, and then I want you to try this one. I want you to calculate the molecular mass for magnesium. Oh, you know what? I think I'm going to do this one with you. It's got a little bit of a twist to it. Okay, let's get rid of this mess. We're going to calculate the molecular mass of magnesium chlorate, ClO3 bracket 2. Okay. So you have to find your givens. So you're going to go to your periodic table and you're going to find these numbers. You're going to find atomic mass of magnesium, chlorine, and oxygen. So hit pause and go find those. All right, so you should have magnesium at 24.31 atomic mass units, chlorine at 35.45, and oxygen at 16.00. So we're going to then substitute in our numbers following the same process as before. We're going to write molecular mass of Mg bracket ClO3 bracket 2. And I'm going to start a new line equals. Okay, so it's always it's always in your best interest to show as much of your work as you can, because if you make mistakes, I can give you process marks. So we're going to start. We know magnesium. There's only 1 magnesium atom, so it's going to be 24.31 atomic mass units plus. Then we have our chlorine. Now, our chlorine is in a bracket, and there's an invisible 1 after the chlorine. So we know in the chlorate, there is 1 chlorine, but we have 2 chlorates. So this means that we actually have to multiply that atomic mass of chlorine by 2. Okay, and now we have to look at the oxygen. So in our inner chlorate, we have 3 oxygens, but we have 2 chlorates. So we have to take these 2 numbers and multiply them. And so we actually have 6 oxygen molecule atoms. So we have to multiply 16 by 6. Okay, so when you're doing this, you have to make sure that you are paying attention to how many atoms are in the ion in the bracket, and then multiplying that number by how many ions in total that you have. So if we do the math on this one, I'm just going to do it all in one step because it's pretty straightforward. It's going to be a molecular mass of 191.15 atomic mass units. So you're going to hit pause. Make sure you have this copied down. And I'm going to give you a couple practice to do now. All right, so after you are done, this video is almost finished. I've got 4 molecules for you to practice calculating the molecular mass for. And then if you go to our website and you go to mass relationships and you scroll down, you're going to scroll past all these things at the beginning and you're going to hit molar mass section. There's some videos or some PowerPoints here if you want to look at. But then there is a practice right here where it says practice questions, molar mass. So if you feel like, oh no, that's not what I want you to do. Nope, those are not, that is not the practice for you. Let me see. Nope, I think the only practice I have for you right now is these 4 examples. Give these a shot. It's a pretty easy, straightforward concept, but we're going to use the molar mass, the molecular mass a lot in the very near future. So do these for practice, and then you are done looking at this.